Hello everyone. So today I am Aswini Kumar Sinha, and today we are going to talk about how you can make a very power-saving device using the ESP chips or ESP-based device or ESP-based development board. So we will use here we will use the deep sleep method of the ESP chip to make a power-saving device. So here we are using the dev board. Here we are using today each this one. The 1 minute. Let me show you. Yeah. Yeah, so we are going to use dev board, Indus board. This Indus board have ESP32S2 chip and a low power processor. So you can put the main chip on the sleep and use the save the power, and you can bake the main chip whenever you want, and you can also use the coprocessor while the main chip in sleep and do the processing and save the power. So or you can use any other ESP32 chips that have the coprocessor, or any other ESP32 chips that have the sleep function, because most of the ESP32 chips have the sleep function. So it is not necessary that you need to use the Indus board. You can use any board, but I am using Indus board because of the coprocessor. So we can make the main sleep main chip in the sleep and use the coprocessor. So here I have designed one of the watch. So in the today project we will make this kind of watch that consumes less than uh, uh, while it is in deep sleep, it consumes less than when it back from the sleep, it consumes around 100 milliamps to 200 milliamps, under which it can do all processing. And then we will also make a smart sensor node, using which we will use the built-in sensor of this board, of in this Indus board, and we will make a super power saving device that actually only use around 25 milliamps to 30 milliamps while doing all the processing. And while in deep sleep, it only consumes around 10 microamps, 10 to 20 microamps. So we will make those device. So as you can see here, I have designed the watch that is displaying the location, and then it will go into the sleep. Right now I have turned this sleep timing to the 30 seconds. So after every 30 seconds, the watch will go into the sleep, and after every 30 seconds, the watch will again wake and show me the things. So for showing you, I have put the sleep to the 30 second only, but for the for actual deployment, you can put the watch for sleep on the interval of 1 hour, 2 hour, or if you more if you want to get the location or get some certain sensor data for only once in the day, then they can even put the whole thing, whole this whole device sleep for the 1 day, and after every 1 day it will wake and do the processing, tell you the data on the display, or send the data to the cloud, and then again put into the again go into the sleep. So we will check how we can make such a power saving device. So as you can see, this Indus board have the ESP32S2 chips, and on this chip this Indus board have ESP chip, and on this chip, this chip have multiple give you the functionality this board gives you the functionality to select multiple of the frequency range. So, and each frequency range use its own consume less power. So currently my chip is on 240 megahertz. So up to 80 megahertz we can use the Wi-Fi, and each when I lower the clock frequency of the chip, the power consumption also become the less. And if we go to the 10 megahertz, that will it will consume much lesser power. So we can select the megahertz of the whole frequency of the chip here, and save the power from here as well. And as you can see, there are different levels of powers it will consume. Around 10 megahertz, it will the this in this board will only consumes around this Indus board will only consume around the 9 milliamps. And at the 40 megahertz, this consumes around 60 milliamps only. And at 80 megahertz, it consumes around 21 milliamps only. So this is super power saving device, and using this board we can make a super power saving device. And maybe put the this is the current consumption when the chip is working on, and it is using the chip is on wake. So if I put the chip main chip in sleep, then on the sleep mode, on the sleep mode, it consumes much lesser power. I'm showing you on the sleep mode. It will, when my main CPU is is in sleep mode, then it will consumes around 750 microamps. So this is very less power. So it will super power efficient board if you want to make any kind of wearable device or sensor node. So this is very power efficient board. You can design many projects that needs power. And for the wearable device and miniature electronics and deployable sensor nodes, where you want to check the data for only once after only 1 hour, or once in a day, or once in a year, then this chip can saves a lots of power. It can even run on the battery for years with if you put the main chip on sleep for a year, and then you need to take data for only once in the year. So for those kind of projects and wearable project, it's been super power saving device, because the chip only consumes around 750 microamps data when it is in sleep. And when I use the ULP processor, the this board have two ULP RIX 5 processors. So if I use the ULP processor on this board, and make the main we will also do the processing, but we will do the very low power processing, and we will make the main chip on the sleep, then it will consumes much lesser power as well. Like it will consumes only 170 microamps. I can even do the processing using ultra low power, and I can use only 170 microamps, and it will save that much of amount. And it have this board have the RTC timer and RTC memory as well. So if you want to keep the track of the time, like what's the month, date, and how long the device is on sleep, so it will use only 25 microamps, while you are using the RTC memory. Overall, it will not going to consume more than the uh, uh, 750 microamps, while it is in deep sleep and using all the GPIOs and ULP processor. It will not consume more than that. And this board also have the sensor on board. So we will design the project that using which we will make a super power saving sensor node that will tracks the movement or any waves in the sea, and can do the processing, and consumes only around 750 or 780 microamps. So the sensor on the board itself also have very low power consumption. So here is the sensor that I have used, that have the magnetometer, accelerometer, and temperature sensor I have used, that consumes only 3 microamps while it is in sleep mode. And while it is you are using the sensor, it only use the 0.83 milliamps. So it is very low power consumption thing. So you can make a very small low power consumption wearable device using this. So let's see how we can do that using this board. You can use any other ESP board as well that have the sleep function, but I'm using this board because this board also have the coprocessor. So we can and this also consumes much lesser power than the other board, and it also has the built-in sensor that also consumes much lesser power than the other board. So that's why I'm using it. But if you want to use any other ESP board, then it's fine with you. You can also use any other ESP board in this project as well. But I am choosing this because of the ULP processor. That's the only thing. So let's see how we can make design the power saving device like this watch. So so for that we will use the deep sleeping method. So here I have the code for the deep sleep. So suppose that let's start from the very basic one. So here I have the Indus board. Here I have the Indus board, and let's make a project on which it connect to the Wi-Fi and do some processing, send the data, and then again it sleep to the go to the sleep the time amount I want. So for that I have to set the Wi-Fi and all of the other functionality, and whatever the sensor or data you want to update or do, you can do these codings in the loop function. And then I will make the main chip connect with the Wi-Fi, And for the power saving, I can use I can even control its power, its wi-fi power, its wi-fi power consumption using this the wi-fi tx power minus 18 dm. So it will consume even less power. These are people that it will consume. So you can also use you can also control the wi-fi power, how much power wi-fi will consume using these things. So I have used to the 1 dm, so the wi-fi power will consume very less. And after that, if after that, if I want to sleep the device for every 30 seconds, so that I want my sensor node to take the sensor data and do some processing and wake up after the 30 seconds. So I will use this line: ESP sleep enable timer wake up at 6E60. So 60E6, yes, this thing is for the 30 second, 60 seconds. So if I want, if you want to make the device for sleep for for 2 minutes or 1 hour, you can change by changing the seconds here. Or if you want to change make my device sleep for the 30 second only, then I can simply put 30 here. So let's here, so let's for for showing for because 60 seconds is very large amount of time for you to wait and see the device is waking and sleeping, and showing that giving showing with the table. So I'm using the 30 second here. So I will make the device sleep for the 30 seconds. So every 30 seconds, this device will do the will wake, connect to the wi-fi, and whatever the processing it need to do, it do that processing, and then it will go to the 30 second again, to sleep for the 30 second again, for the demo person. Otherwise you can use make this device sleep for 1 day, 2 day, or 1 hour, whatever the interval of time you want to make this device to sleep. So while in sleep, this device will only consumes around 750 microamps, you can see in the data sheet. So I am connecting this device and uploading this code, and then this device uh, uh, will run on that code, and it will consume that much power. So I'm uploading this code. So this is how you can make the main chips in sleep, and save the power on your device, and use the power of the indus board of this board to and make a very super power saving device. And now the code is uploaded. As you can see, the code is uploaded. You can ignore this message because it's the Arduino ID message. The code had already uploaded. And then when I open the serial monitor, yeah, here is the serial monitor open. 1 minute. Yeah. Now when I open the serial monitor, it will do the processing and then connect to the wi-fi and then go to the sleep. And again after 30 seconds it wake up, and it will do the processing, and then again it will go into the sleep. So right now a device is going to sleep. It will work like this. I am showing you the demo here using the video. 1 minute, let me show you the video. So like this, it will connect to the wi-fi, show you the ip address, and then it will answer you that it is going to the sleep mode, and then serial port got disconnected. Then when it wake, the serial port automatically get connected, and it will show you the message that that is the ip address connected to the wi-fi. And again it will go into the deep sleep mode, and it will disconnect to to the serial port, because chip is in sleep. And again after 30 seconds the chip will wake up. So this is how this code will work. And while using the sleep function, it will use like this, as you can see, connected ip address entering the sleep mode. And again it get connected, and then it show me the ip address to the processing, and connected to the wi-fi, send the data to the iot or whatever the function you said. And then again it enter into the deep sleep mode. And while in deep sleep mode, it only consumes 750 microamps. So it is saving the power right now, and it is running only on 750 microamps. And then again it will wake and do the processing and go into the sleep after 30 seconds. After 30 seconds, see, after 30 seconds, the chip will wake up, do the processing, send that IoT data to this address, and then again enter into the deep sleep mode. So this is how you can put the chip into the deep sleep mode. Now next, look the next go to the next level. So suppose that I want to design, IP based location tracker of the device. I will not go using the actual GPS. I am using the IP based location tracker. So what will it will do? It will track the location of me using the IP address, and using the Wi-Fi network around me, and then find the IP address, show me the current location, and then again go into the sleep. So how to do it? Let's check it. So, and using the deep sleep. So suppose that I want to make a device that once in a day, it will take, it will give you the location where it is, and then go into the sleep. So at every for the whole day, it will consume only 750 microamps, and for the 1 second the device will wake up and consumes 300 milliamps, and then again go to the microamps. So it will consume very less amount of battery and do your jobs. So for that, I have code. So here what we will do, we will check, set the SSID or password of the Wi-Fi that it need to be get connected, and then we will create a function for get location, so that it will get the location from my SSID and Wi-Fi around it, and then we will print those location on the serial monitor. After getting the location, it will print out, and printing this location telling the where the device is located. It will go into the deep sleep for the 30 second using this deep sleep function, and then we will use the deep sleep start function. So it will start sleeping and wake up for the 30 second, and then again go to the sleep for the 30 second, and show us the IP, the location, and again go to the sleep. So while in sleeping, as I said, it only takes 750 microamps. So it will make a super power saving location tracking device without based on the SSID. So this device, I am uploading that code to this device for the demo purpose. I am using the 30 second. Otherwise you can put this deep sleep for 1 minute, 2 minute, or 1 hour, but because 1 hour is too late, so that I can show you that this chip is in deep sleep now, it's wake up. I will, it will not feasible to show you in the live demo for the 1 hour deep sleep. So I am making this chip sleep for only 30 seconds, and then it will do. But you can change this sleep function to the amount of time, to the year, a month, or whatever the amount of time you want, you can change this. So what how our code will flow is, we connect to the Wi-Fi, then get the location, and then tell us the location, and then go into the sleep for the 30 second, and then again it will wake up and show us the location. So let's upload this code. So I am uploading this code. So right now I am using 240 megahertz of the Wi-Fi. You can use the 80 megahertz as well to consume even less power from the chip. 1 minute. One thing is, when chip is in sleep, the it will connect it to the USB port. So when the chip is in sleep, it will so the code is running, and it put the main chip on the sleep. So when the chip is in sleep, you can't it can't read the serial port because the main chip is in sleep. So what we will do, when you use the deep sleep method and want to upgrade the firmware, you can do one thing. Because main chip is in sleep, it will not show you the serial port. So what you will do, you can unplug the device, and then put the reset button. Here is the boot button. So when I press the boot button and plug it, it will not run the code, and it will in download mode. So you can put the main processor in the download mode. So code will be not going to sleep, and then we will upload it out. So now code is uploading here. One minute, let me upload the code again. So I'm uploading the code on this board again. Okay, 1 minute. So now code is uploading for the IP location. So what it will do, after uploading this code, it will connect to my Wi-Fi, and then now I am opening the serial monitor. Okay. Now it will connect to, then it will show me the IP address and the location, and then go into the sleep again. So now this code is running. I am showing you. So it is connected to the Wi-Fi. Show me the show me the location on the, and now you can see the serial port got disconnected because chip is in sleep mode. So it will sleep for the 30 seconds, and after 30 seconds it will again wake up, tell me the IP address, the country code, and my location, and everything details, and do the processing whatever it is said to be, and then again it will wake up, and again, then again it will sleep. So here you can see. So here is the chip. 1 minute. So here is the device running on the deep sleep, and here is the here is the chip giving me the details of the location after every 30 seconds, and it will go into the sleep. So while doing all these jobs, it will only consuming around 100 milli 100 milli 100 to 200 milliamps while processing, and after when it go into the sleep for the 30 second, it will only using 750 microamps. So it is very low power consumption, and it can run on battery for even more than a month. So as you can see, so again chip got wake up, and it is showing those data. So this is how it is work. So let's now design the next project. Let's design a smart watch, like you have seen the watch. So whatever watch will do, it will go into the sleep, do some after every 30 seconds, show some data, and again go to the sleep to second to save the power. So while in only consumes around 200 milliamps to 300 milliamps. No, while working, it only consumes around 200 milliamps to 300 milliamps, and when in sleep, it only consumes around 900 microamps to 600 microamps, because display also consumes little bit of power. So I am using here the display, as you can see. I am here using the display connected with this Indus board. Now what it will do, it will do the processing, show the data, and then get the main processor on the sleep, and use the coprocessor, the ultra low power processor consuming only 700 microamps, and then keep displaying those things, and then again make the main processor and do the processing and show me the data. So here I have plugged in. See, see, it is in sleep mode and it is showing the message. It is in sleep mode, as you can see. And again it will show me the latitude, longitude, and the IP address. Then again go to the sleep mode. So after every 30 second it will go to the sleep mode to save the power. And after every 30 second it will again wake up to show me the address. So this will happen for every 30 seconds. So when it is in sleep it will consume very less power, and then it wake up the main processor and do the processing, then again put the main processor on the sleep. And it can this is how this you can design the super power saving device that consumes around only even if I use the built-in sensor of the board, that is gyro center, temperature sensor, and other sensor, it will consume only 3 microamps while in sleep, and only 0.8 milliamps. It is very low power. 0.8 milliamps for the sensor, and use only 750 microamps while in sleep, and around uh, 28 milliamps while in working conditions. So it will not consume much power, and it will do the lots of power saving. So this is how you can design super power saving device using our wearable device using this Indus board, or using any other similar ports based on the ESP chip, based on the ESP chip. Okay. So if you have any question, you can ask me any question. And whole project will be, you will get the whole project soon on indus at electronicsforyou.com. Here, whole project will be published soon, or also on electronics for you website. And this project not only can be made on the indus board, it can be made on any esp board. So it is not necessary that you have to be the indus board. You can use the esp32 development board, esp32 a stock m5 stock board, or any other esp board that have the sleep function. But I'm using this board only because of the coprocessor, because most of those boards the have do not have the coprocessor RISC-V ultra low power coprocessor. So even where my main processor is in sleep, I can use the coprocessor for little bit of processing. So only for that reason I've used, and because of the small size for designing the smallest sensor, only for that reason. Otherwise you can use any other board. It is not necessary. The same code will work for the ESP development board, and same code will work for the other M5 stock or other ESP32 bits board. The same code will work, same project will work. Only the ultra low power processor will not work. It will only work on this board. So so that's the only reason. So if you have any question, you can ask me. Okay, thank you. So I'm not getting any question. Hope. Okay. Okay, thank you everyone. Thank you. Hope you have lots of learning from this, and you can always get the whole code and whole video of this thing will be soon published on indusboard or electronicsforyou.com. Okay.